Hello everyone, my name is Dawn from Dragonfox Studios and welcome to part 1 of Project Alpha. Project Alpha will generally be a more realistic focus tutorial series, realistic in quotations because we will have our limitations, mainly visuals. And with this project series I want to get a more active project flow going and actually show people how to prototype specific things, how they can implement it. And in part 1, we will generally make a basic movement system, which includes sprinting, crouching, and proning. With these, we will also have animations in place for that, but the project is mainly focused on gameplay, so animations will be more quick and dirty. But with this said, let's actually get right into it and start with the project. So I'm running in 4.24 and I have my development project here. So what I'm gonna do is I'm gonna make a games project. I am gonna use a blank template because we're gonna use something from the asset store, which is free for our animations and all that basic stuff. And here we want blueprint, everything else is all right. We don't need no starter content. So what we're gonna call this is, I'm gonna call it Project Alpha. There we go. And let's just create this project. After we create this project, I want to open my games launcher, go to marketplace, and very quickly for animation starter pack. There we go. And we just want to add it to our project Alpha. There we go. And now we will have access to some basic animations. So the next step will be, I'm gonna create a assets folder because I like keeping my stuff a bit more clean. And then I will make a animations folder. And in that assets folder, I will also make a character folder. And I move my mannequin into my character folder. So, and after we moved our character over, let's fix up redirectories in folder, just making sure our redirectories are fixed. And what I will do then is delete this folder. And then we have a bunch of animations, so we can pretty much get rid of most things. I'm gonna get rid of this character. So let me go in the AnimBP first, because all this stuff we're gonna have to redo, because from default it has it's using the hip animations, which don't really fit in what we want to work on. So let's make everything disappear besides our idle state. And then here we want to delete this one, yes. And we don't want a showcase. I'm also gonna go ahead and delete all hip animations. Which is gonna take a second. Then I'm gonna delete all hit animations. And delete all def animations. There you go. So what we're left with is now a few animations and our AnimBP. So what I'm gonna call this AnimBP is AnimBP and mannequin. There you go. And for this mannequin, I am going into my animations folder and making a AnimBP folder and also a blend space folder. That will become important in a bit. So move this into AnimBP, get rid of those two aim offset, not aim offsets, but blend spaces. And let me look, yeah, and the rest of the animations we want to move into animations. And what I want to also do is make a aim offset folder, which will be for our aim offset. So yeah, this is the one we need. We're gonna need to take this aim space iron sights into our aim offset folder and copy it 3 times. 2, 3. What I'm gonna do after all they got graded, I'm gonna take the first one, call it aim and backup. This will be the one that doesn't get modified. Then I'm gonna call this aim up. Rename aim down and aim center. With aim center, what I'm gonna do is I'm gonna take this all the way to 0 and then move frame 1 to 78. So now we only have that aim center frame, which we're gonna use in our aim offset 1D. Next, I'm gonna go into my aim down and look where the player actually starts aiming down, and then try to hone in on that frame. And then I right click on here. We want to delete 0 to 19 and 1 to 86. So now we only have the frame of the character looking down. We can save that. Also, now we can just do the aim up, which I think is at frame 10. Let me look from the side. So I want to just get the highest position before it goes down again. So it's right here, 0 to 10 and 1 to 87. There we go. And now we have this. And what I want to do is, before I continue, is I make a copy of this one. And this is I'm gonna call center reference. This will be just important for, in a second I'm gonna explain what I'm using it for. So I'm gonna take those 3, asset actions, bulk edit via matrix property, and we wanna go into adaptive settings, mesh space, animation frame, and our animation frame will be our center reference. Okay, I can't. Center reference. So what we should have now is we should have those aim offsets properly when we now create the aim offset 1D. So let me just do that really quickly. Go into animation, aim offset 1D, take our skeleton, and this is gonna be aim AO rifle. And in AO rifle, what we want to do, let me just really quickly look that up so I don't do it wrong. So we want to have, in our horizontal axis, we want to have -90 till 90, and -90 in our case will be down. So let me take my aim down, aim up, and aim center. And if we move that now around, we can see our character aiming up and down. One thing I'm generally also a bit confused about, if anybody has an answer to this, why his arm slightly bulges out and bulges back in, it is very confusing to me. If anybody has a fix for that, that would be generally great, because that's an issue I've run in more than once. Okay, but this is our aim offset. So what we do next is we go into our mannequin. And what we're gonna do in here is we're gonna place idle rifle, iron sights. There you go. This is our starting position. And we just made a aim offset. Also, this is just so an idle animation place. We're gonna add a lot more in a second. But let me get back to the graph, and in here I want to AO rifle offset AO. What we're gonna do is we're just gonna hook this up, and then we're gonna create a variable here which will be our aim offset. There you go. And if we change this to 20, player starts looking up, 45, 90. Okay. So right now, though, we can see clearly that it's jiggling a bit, and especially with something with a game that has a bigger focus on things needing to be accurate, I'm going to remove those idle frames because there's way too much jiggle in there, and I'm probably going to replace that later with one that has way less wiggle. So let's go back into our animations, and I'm going into my idle animations, and what I'm going to do is pretty much go to frame 0 and remove everything after frame 0. So we have a static frame. So also with those iron sights here. All right, and I think there's one more. Yeah, our prone idle. Yeah, let me try to get frame 0. There we go. Now we have pretty much a few, and now you can see we don't have any more of that jiggle. We should later still have some jiggle, but we should have the upper body be mostly static, maybe some slight moving up and down, but nothing major like we had it before with the default animations. Next up, I want to create the basic player blueprint. So what I'm gonna do is I'm gonna create a new folder, and I'm gonna call this a blueprint folder. And in this blueprint folder, I want to make a blueprint class, and which is gonna be a character. I'm gonna prefix my character with CHAR for character, and I'm gonna, in my case, call this character main. In this character main, we will need to do a few things. For that, let me open up my character main here. And what we want to start with is we want to, oops, we don't need to add a mesh. We can just add our skeleton here and then fix the location of the skeleton, which should be -90 over here and minus 90 over here. So we have it facing forward, what we want. Then I am going to add a camera, and I'm gonna route this to do the head. And luckily I already made this, so I can just, oops. Actually, I think I'm gonna add a spring arm. Actually, no, I can just, actually, yeah, I'm gonna add a spring arm. So let me just add a spring arm as an intermediate component. So let's set this as the head. So head, there we go. Zero this out. Apologize for that, because it will be a little easier to work with. And then what I don't want to inherit any of this, because we're gonna do the inheritation manually and set this to roughly 4.5, set this to 0, 4.5, around 8.25, and the third one is around 2.5. There you go. And if we now go ahead and give our character our NMBP mannequin, there you go. Now we can see the camera is quite an okay position, and if we would go ahead and get a game mode base, and let me drag that character into game mode base and drag this into here. Click play. We can roughly see where our camera is. It should be roughly on rifle height, and this should generally work. We might need to adjust later when we actually add weapons to the game and all that stuff, but for now, this will work. Then I'm going into my project settings and adding a few inputs. What kind of inputs do we need? We need inputs for crouching, standing, and we need inputs for sprinting. We need inputs for looking up and down, left and right, And also we need inputs for moving forward, backward, and right and left. So input crouch, and let me bind this to my C key. Input prone. Let me bind this to my Y because I'm on a QWERTY keyboard, so my Y is on the bottom left. And here, let's move forward, move right, so W and S. And whoops, S. And with my S key, I want this to be in the negative. So when I, give me 1 second. Apologize for this. Why is it? There we go. So when I go backwards, S would, so if I press W, we want to go forward, so 1. And when I press S, we want to go backwards, so -1. So we go forward with 1 and backwards with -1. Then what I want to do next is move right. In our case, D is right and A is left. So when we press, oops, and I want to be -1, not -1 point some odd number, because D in this case will be our right and A will be our left. All right. So with all those inputs now in place, oops, I actually forgot something. So we also want mouse X and mouse Y. So mouse pitch will be our mouse Y, and mouse yaw will be our mouse X. Okay. Now we have all our inputs. So what we can start doing now is generally setting up the basic logic. But I think I'm gonna make a enum first for determining our state. So in here, I'm gonna make a new folder called data. And I think I can just very quickly also fix up redirectories and delete this folder. So in our data, I'm gonna make a new folder called enum. And in that folder enum, I'm gonna make a blueprint enum e_stats. I think I'm gonna call it stats type. There we go. And in our case, we will have 3 stances: standing, stand, crouch, and prone. I'm gonna use an enum because that's one of the easiest way to flip through states. And especially if we want to later also count weight into everything and give everything different speeds depending on the stance, it's very useful to just have an enum, so you have an easy way to replicate it and do a rep notify, which I'm gonna show in a second, of when a stance changes, we can change the speed with it. All right, so let's just continue with our animations, our blueprint setup. So let's start setting up some basic stance changes. So if we take our prone input and our crouch input, input crouch, there we go. We want to create a variable and a function, a event to call this variable on the server, because we want to make sure our stances are being replicated. The reason for that is we want to know on all available clients in the area what stance the player is in. So how we will do this, we want to create a variable and we're gonna call this how did I call stance type, And this is gonna be our player stance. There we go. And this player stance variable should be rep notify. The reason why we don't just make it a replicated variable is replicated would work, but we won't have an easy way for telling all available clients that, oh, this player changed his state and you all need to change your state too. And not just state, but like you need to also change your current walk speed. All right. Then what we want to make is a custom event. I'm gonna prefix this with ROS, which in my case stands for run on server, and change player stats. There we go. And we're just gonna set a stance here. What we can do later is also do some more logic in here to maybe limit stance when the player is somewhere or something. This is especially useful when we have, for example, a player in a corridor and we have, for example, a hitbox above him and he can only crouch, and when he tries to stand, he won't be able to, he will only be able to crouch. And yeah, with this we could limit this. But let me... Also, I have like if I have nodes like this, I'm just gonna select them and press Q. This is a default bind in UE 4.24, I think, to auto align some nodes, which is good for keeping things clean. And over here in our input prone, what do we want? We need to think about what we want and how we want stances to change. In my case, if I press prone and then prone again, I want to stand, so I want to prone down and stand up again. So how we can approach this is we can make a call to our RS stance change, and in here we're gonna take a select node. With the select node, we can just check if our player, oops, that's the wrong node, but we can check if our player is prone. And if our player is prone, we want to change it back to stance, and if false, we want to change it to prone. And we can just copy paste this down here. And what we want to do in here is we want to use crouch. So if we are proning and we want to go into crouch, it won't go prone, stand, crouch. It will go prone, crouch, and the other way around. So unless it's crouch, when you press crouch, for example, the player won't just stand up. He will just go back to the other stance you want. It's very useful, especially if you just want to flip through stances. So we also don't need a third keybind for making just a keybind for the player to stand up or something like that. It just keeps it more contained. Then the next thing I want to have a look at is just sprint. Oops. Did we set it up? I might have forgotten it. I apologize if I did. Let's go into defenses, but project settings, input, and yes, input sprint. And we wanna left shift this. So in here now, when we press left shift, we wanna call a server event because we want to make sure stuff is getting set on the server before it's getting set on the client. So also what we want to do with sprint is you aren't really able to sprint while proning or while crouching. So we want to limit this to standing only. So how we can do this is we can make a custom event. We're gonna call this OS update speed, update sprint, not speed, update sprint, and we can have a condition in here which is wants to sprint. Then in here, we can hook this up and make a new variable, which is a Boolean, which is probably just something is sprinting. And if we want to stop sprinting, we just go the false path, because we don't need to check anything if we want to stop sprinting. Then in here, we want to set this to replicated. And in a second, we're gonna make a function. Actually, let's just make this, which is update speed. We won't put anything in there. It will just be a placeholder for now. So after this, you want to call this function. So what we want to do over here now is we want to call our iOS update sprint. And on true, it's true. And on false, it's false. So also, let's make this run on server. There we go. So we go in here. We're gonna request the server if we are allowed to sprint. If we are allowed to sprint, if we want to sprint, we just go in here. We check if we want to sprint. If not, we set sprinting to false and we call our update speed. But if true, we want to check if the player is standing. So we're gonna just do a simple enum check and check if he's standing. If he's standing, we want to set sprinting to true and update our character speed. Just like this. So we have a condition check. So we can only sprint if we're standing. Otherwise, we won't be able to sprint. And what we're gonna do next is, I think we wanna go and update speed. And what we're gonna do is we're gonna go in here and first of all change the max walk speed to something like 200. Max walk speed will, because not 2, but just 200. And then on here, max walk speed. Oops, we want a setter. We want to set max walk speed. And what we're gonna use here is we use a selector, because we want to determine, depending on what state we're in, how fast we can go. So let me just set 100 for prone, 150 for crouch. Those are not accurate values. I'm just currently using placeholder values so we can actually see what's going on. And then over here, I want to do another select, because we have two states on walking, and false in our case will be walking and true will be sprinting. So every time we update our function here and it calls update sprint, we update player movement. But I think what I need to do is set this to replicate and notify, and not deal with update sprint in here, but inside here. Because I just found a flaw with my original code, is because we were calling this just on the client, but we need to call this on all clients so it works properly. So all clients have the same speed and there's no desync between client and server. So when sprinting is getting updated, we are calling our update speed variable, update speed function, which calls it on all available clients. We also want to call our update speed function on when we replicate our new stance. So every time we change stance and every time we change if we're sprinting, we want to recalculate our max walk speed. All right, I think that is pretty simple in general. And yeah, if anybody has questions about anything I'm doing, please make sure to ask me down below. Then we're done with sprint, we're done with changing state. What we want to do next will be a bit more complicated. So the first thing will be just our mouse yaw. This we can just add controller input yaw. So this way we update our rotation. We should also be able to just show this. So if I now see when I move my mouse left and right, our character turns. It looks a bit weird right now because we don't have our camera turning with the player, but we will fix that in a second. So when we go back in here and we want to add a mouse pitch event, this mouse pitch event will be a bit more math heavy because we will need to round out a location, and then with this round location we need to set this to our aiming angle. But don't worry, I'm gonna walk you through this. So what we want to do next is we want to work with the pitch. So what we're gonna do, first of all, I had to fix something because I made a mistake, which in the mouse Y I set this to -1. That's all I did, and I did some debugging here, which I am sorry for, which I'm gonna remove now because we don't need it. Okay, what I'm gonna do here is I'm gonna add a mouse pitch, which is our up and down looking. And the first thing I'm gonna do is, because we can't do the normal way of adding pitch and removing pitch because we need to later clamp the value, that is why I need to manually add the control rotation to the pitch. So let's get control rotation, split this, and let's take our pitch. So here we just take the incoming value plus our pitch, and then we check if our incoming value is, whoops, that's the wrong way around. So we want to check if it's more than 100, because if it's more than 100, we want to add 360 to it. There you go. So let's add 360. But if it's not more than that, we just want to take the value how it is in there. Then we want to minus 360. And then we want to clamp it between -90 and 90. So, to really quickly go over what we're actually doing. We want to get negative values, but the control rotation only gives you values from 0 to 360. So we need to do a little workaround, because if you look down, the value is normally 270, and if you look up, it's 90. So it would be a range from 270 to 90. So it's the 180 degrees, but it's offset a little. So what I'm doing is, if it's more than 100, I add 360. So if we, for example, have, right now we have less than 100, so let's say 90, we don't want to add anything because, well, wait. Oh yeah, we don't want to add anything if our value up here is more than 100. The reason for this is because the value would only be over 100 if it's 270. So if we look down, it would be 270, and if we look up, it would be 90. But we would need it to have minus values. So what we do is we take this 90 plus 360, and we take the normal value just how it is, and then we minus 360, and we receive, if we look down, minus 90, and if we look up, 90. Yeah, it's a bit confusing, but it works. And then we want to get our player controller, and we want to set our control rotation, and our control rotation needs to be, whoops, let's split this, needs to, also we need to get our control rotation, because we just want to update our pitch. But we can't update our pitch yet, because if we would update our pitch, we won't have any of the benefits of the thing we just made. So what we want to run this through is we want to run this through a clamp function. So this is going to be a simple math function, which is clamp aim angle. And in here, we want to just have a return node, and both those nodes needs to be floats. Which is unclamped angle, and then this is clamped angle. So both of those should be floats. And the first thing we want to do is we want to get our player stance, because depending on the player stance, we want to limit the player's look at direction. So the first thing we want to check if, that's the wrong one, we want to check if it's proning. No, wait, we want to check if it's crouching. And then we run this into a select node, and we run this right into the output, because, yeah. Then we want to check if we're proning. So if we're not crouching, we want to check if we're proning. And then we want two clamps, float clamps. So clamp float. And what we do here is we could even add 3 clamps if we want to clamp it while standing, but I don't want to do that right now. So I'm not gonna add any clamping for standing. So actually, let me make this a bit more beautiful. So just like this. If we're proning, we want to only look up 45. Yeah, I think that's fine. Look up at 45, but not be able to look down, because if we would look down, we would look into the floor. And with crouching, we want to add 45 to 45. Could probably go a bit higher, but I know this works and it doesn't look too stupid. So if we go now back in our graph and take our clamping aim angle function, and we put this in here and the second one in here, we would have our control rotation update logic. But we want to do a little bit more, because what we want to do is we want to now update the spring arm. So we want to set relative rotation. And we can just get our control rotation. And if we now click play, oops, I think that's the wrong way around. Yeah. I need to multiply by -1. So multiply by -1. Because I was just realizing if I look up if I look up, now I look up. If I look left, I look left. If I look right, I look right. And we can look properly up and down. Now I'm crouching. And now I'm proning, I can only look up. When I'm crouching, I can only look up and down. And if I'm standing, I can look all the way up and all the way down. So that is done. The next thing is now we don't have this replicated. So what we want to do is we want to replicate this function. So what I'm going to do is I'm going to make a new replicated variable, which is going to be a aim angle, which is a float. And what we want to do with this aim angle is we want to make a custom event, AOS update aim angle. I'm always worried I'm calling it angel, but I know it's angle. So we want to run this on server, and up here we want to call AOS update aim angle. So every time we update this, I need, you know what? I even have a better way, because then it doesn't break rotator. Then it doesn't recalculate this value here. So what I'm doing is on the client, I'm calculating the new look at rotation, the new pitch location. And this pitch location gets set to the control rotation, and this control rotation I'm gonna take afterwards to forward to the server to let everybody know where the hell this player is looking at. Also, I need to make this replicated. And this is nearly everything for this character. The only things left would be to set up the movement. So what I'm gonna take here, move forward and move right. There you go. For both of those, we want to get our control rotation, break this control rotation, oops, break rotator, and we want to make a rotator. Why do we do this? Because we want to zero out the Z location. Because we don't want to worry about our roll or our pitch. We only care about the yaw, which direction we're facing. And from this, we're gonna get our forward vector and our right vector. So depending on our rotation, our character rotation, what we're looking at, that will determine our new north, our new forward. So if we, for example, at 360 degrees and we get the forward vector, we would get the normalized vector depending on this rotation. And we can easily get the right vector from that normalized rotation. So with this, we can determine the current look at the rotation, and depending on where the player is currently looking at, we can use the new north or forward vector. Okay, so next thing I want to do is just add a movement input on both axes, just like this. And now we should be able to move around our player. So we can already see if we press shift, we're sprinting. And yeah. So the next thing, and probably last thing, will be setting up the actual anim BP. So let me take a short break and I'll be right back fixing up. So let's continue with creating our blend spaces. For that, I just went really quickly into our folder, in our blend spaces folder. Oops. Yeah, let's actually save this as. Also, make it maps folder. I'm gonna prefix my maps as m_test map. There we go. So we have our test map now. And in here, I want to create an animation blend space. So bs_walk, and we want another blend space, which will be bs_crouch. So we have a crouching blend space and a walking blend space. So let me start with the walking one. So up here, we want to have direction. The direction we won't be using for now, but we can later implement this if we do some more detailed stuff. So which direction would be -180 and 180. It's for walking, determining if we're walking forward or backward, right or left. All right, and this here is speed, or better said velocity, because we're gonna get our velocity, not our speed. And this is from 0 to 200. We should make this 0 to 500, but we don't have any running animation. So I'm actually gonna make this 0 to 500, but I'm just gonna use my normal walking animation. So what I'm gonna do is I'm gonna get walk, get my backwards ones, which go left and right. Then I'm gonna take my walk forward ones, which go in the middle, and my walk left ones, which go left, and my walk right ones, which go right. So now we have just simple, we can go forward and backwards, we can go right We can go backwards. And yeah, we only have logic for backwards and forwards for now, but I want to add the other stuff later down the line. And I just want to have them already in place. All right, this is our blind space walk. So let's go into our blind space crouch. So let's just look for crouch. And this is our direction again, minus 180 to 180. And velocity, which in our case will be 0 to 150. So this is our backwards one, which goes in all four corners. Then our left one, which goes on the left side. Our right one, which goes on the right side. And then our forward one, which goes right here. So forward, right, backwards, and all that. So we now have this. Now we're gonna do something a bit more complicated, which will be dealing with our actual NMBP. It's more messy than complicated, but we should manage that. So in our NMBP, there we go. We have our AO offset, which doesn't work currently because we haven't added the logic for it, but that will be the thing in a second. So let's go in our event graph. And the first thing we're gonna do is we're gonna try to get our pawn owner. And if we can get it, we want to cast to character main. With that, we can get our player state, player stance, not state, player stance. And we're gonna promote this to a local variable, which is our player stance, or just stance. With this, we now got our stance, so we can work with doing animation depending on the stance. Then the next thing is I want to get velocity, and I want to get the length of this, so vector length. So what it does is pretty much velocity get vector length is getting the length of the vector, meaning how big the vector is. So for example, if we had 600, 300, the length of the vector would be 900 because it adds the 600 plus the 300. I think at least. It's vector math is still something that's a bit over my head, but I'm trying to get used to it. But I know if we, for example, but yeah. Then we want to just promote this to a variable, which is our actor speed. So we're just gonna add, you know what, let's call this velocity because it's our velocity. And the last thing is we want to get our aim angle. But the issue with this is it might be a bit too harsh how quickly we can look up and down. So I want to smooth it out a bit. So I'm gonna make this a local variable, which I'm gonna call angle. But how I'm gonna set this is I'm gonna go f_interp2. Interp2. What a f_interpolate is, it smoothly takes value A to value B. In our case, current is our angle. And this is our target. The delta time is the time of... Wait, is delta time the frame update time? I think so, but we get the word delta time in seconds. And down here we can determine how quickly we want to update this. I think 15 is a good number, but you can play around it and find the value you want to use for it. And yeah, now I hook this up. And in the anim graph, so let me also go over here in the anim graph, we now have our aim offsets, which, aim offset, we're gonna replace with angle because I completely forgot that I made a aim offset variable. So let's get rid of this. And if we go click play, we can use our aim offset, and it's slightly, ooh, okay, something is going weird. I never ran into this, so let me really quickly look at the fix and I'll be right back. So we had an issue because I forgot to do something. So first of all, let me make this not pure. And we're gonna take this clamped angle and we're gonna take this in here instead of our control rotation. Now that we did this, the issue was we were getting the original control rotation again instead of our new logic, which was my mistake, but with this we're gonna fix it. And in here now, I just really quickly added a new clamp float, which clamps it between 80 and 80. All right, the reason why I clamped this between -80 and 80 is so we don't get overextension of our animation. So if we click play now and we look down and we look up, we can see that we don't get this overextension anymore because we're now on the bottom. And if we crouch, quote unquote crouch, you can see that we can only aim limited, and if we prone, we can only look up. So we're gonna now actually add animations to this so it doesn't look weird anymore. So when we go into our locomotion graph, there we go, and we need a few stats. So the first one is just our idle stat. Then we want to add a new state, which is walking. Then we want to add a new state, which is crouching. Then we want to add a new state, which is crouching idle. And we want to add a new state, which is prone. Now I'm just gonna connect them all up because I already have this set up, because I'm not good at animations. This is still something I need to get better at, but I can connect all the lines we need. And then really quickly go over why I connected them the way I connected them. Just like this, and then just like this, and then just like this, and then just like this. So what do we have here? We can go from idle to walking, crouching idle, or prone. So if we are crouching but we're idle, like if we're crouching, we go into here. But if we're crouching and walking, we go into here. If we're walking and then deciding to change to crouching walking, we go into here. And if we are going from idle, or crouching into prone, it just goes like this. And if we're walking, it goes over here and then in here. So let's set up those nodes. So if our stance, oops, I deleted the wrong one. If our stance is equal to standing and our velocity is more than 10, so we're gonna check if we're actually moving, we can enter the walking state. So this was this one up here. And now we go on the bottom one of this, and we're gonna check on this one if we're not more moving. So if we're less, oops, that's not less than 10. So if we're less than 10, we don't move. We just stand still. So we have those two nodes then. Let me go back in here, copy this one. So if we're walking, so if we're still walking, but we want to go into crouch mode, we can check if we're crouching. And the other way is if we're still moving, but we're standing, we go in this mode. So if we're walking and we press, also I'm gonna populate them in a second. But if we're walking and we press C to go into crouching, we go from walking into crouching. If we were in walking but decide to stop moving and go into crouching, so if it's less than 10 and we want to go into crouching, we go from walking straight down here. But if we want to stand and walk, and while velocity is already higher, we go right back up here. So we now have those notes, which here, 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 and here. I know it can get very easily confusing, so I'm trying to go over everything twice. So when we want to start moving as crouched, we can just check this. So if our stance is crouching and we're quicker than 10, wait. Yeah, and if we're quicker than 10, we want to allow to get into crouching. And the other way around is if we're crouching and our velocity is less than 10. So if our velocity is less than 10, we want to go into idle. So we now have the right side here then. Then let's actually do idle to crouching idle. So if our velocity, if our velocity is less than 10 and we want to into crouching, then we can go into crouching. And the other way around is if we are pretty much the same thing, but standing. So here we check if we're walking. And if we're not walking, we're idle. If we're idle, we check if we can crouch. If we're crouching, we check if we're idle. If we're crouching, we check if we move. If we move crouching, we check if we can go idle. And yeah. And the last thing with prone will be a bit more easy because we can just check. We're gonna check if we wanna be prone, just like this. And we can use that for free of all of them. So the second one and the third one, because we don't have any velocity right now. But here we want to check if we want to stand. Here we want to check if we want to go. My brain. We want to check if we go crouch. And on the bottom one, we want to check if we want to go crouch and have some velocity. So let's check this one, copy this one, and paste it in here, and just crouch. And let me just go very quickly over everything and just make sure it works. So first of all, let's add the crouch stuff. So crouch, idle, rifle, iron sights, there you go. Then we want our crouching blend space, crouch blend space, BS, how did I call the blend spaces? BS crouch, okay. So let me just drag BS crouch in here and take velocity here. So this is our crouching, there you go. And our walking will be BS walk, walk. Let me just drag it in. I think that's easier. There we go. That's our blend space walk and our velocity. Did I do it at velocity or did I? No, that's idle. Yeah, that needs to be in velocity. There we go. And I think that has been, oh wait, no, I need to prone. not reload, but prone idle. There we go. And now if we click play, we should be able to change our stances to crouching, to prone, prone to standing, standing to prone, and crouching, prone. And we still have one issue. This is from walking to prone. So let me keep it here. And there we go. Let's try to make this a bit more visible. Well, it's always a mess working with this. Okay, like this. So those two will now deal with going from walking to prone. So if we can just use this. So if we are standing and we have some velocity, we can go over to this. But if we're standing and we want to go prone, we can just use this because we have no speed check with prone. So now if we check here, if we want to go from prone to walking, we can just easily do this. And if we want to walking to prone, we can just use this. So if we click play now and we go crouching, go walking, go prone, go walking, go prone, go walking. And we can go sprint. And over here, if we look at our second client, if we go crouch, we can see this. If we go prone, we can see this. If we move crouch, we can see this on our first player. And we can just move prone a bit. We don't have any animation for prone, so it looks a bit weird, but we can move prone, we can move crouch, we can move standing, we can run, and everything is replicated. Speed is also replicated, so if we're prone, we're very slow. And it's all on dedicated server, so none of those clients are actually server side, so it's all properly replicated. So yeah. So, but with this said, this was the first part of Project Alpha. If you have any questions, please let me know down below. If you have any feedback in general, what I should be different, what I'm doing good, and generally that, please let me know. We have a Patreon for this project because it will take a lot more work than just me doing tutorials every day. I will also have to do a lot of research for this because I want to do them properly. If you have any questions about anything I did, please let me know. And with that said, I hope you learned something from this tutorial. And with that said, wish you all have a very great day and goodbye.